Solving systems of equation by elimination. So this is my favorite way to solve systems of equations. It, to me, is the least difficult to go back and work through. But each person is probably going to have one that stands out to them as the easiest way. Elimination is whenever we want to knock something out. You use elimination whenever we are solving equations. We use elimination to move a number to the other side. Our goal with elimination is to actually knock out one of the variables early on and then solve for that letter, solve for the other one, and then use substitution to go back in. So elimination has substitution involved with it, but the beginning part's to solve the first one. You're not having to substitute in such a complicated form. So step one, let's look at this function. We have 4x plus 2y equals 9, and the other one is negative 4x plus 3y equals 16. We are going to rewrite that down just in a working spot. Now we are going to add these equations together. That causes your x's to cancel out, leaving us with 2y plus 3y equals 5y. 9 plus 16 is equal to 25. The equal sign will continue to drop down exactly in its same location. Now I'm going to solve that equation 5y equals 25 by dividing both sides by 5. And y is equal to 5. Now I'm going to choose one of my two equations. It does not matter which one I choose. I just take one of my two equations and I am going to substitute in for y that 5. So I'll go ahead and rewrite it just like it is. And I am going to substitute in for that y spot the 5 we solved earlier. And 4x plus 10 is equal to 9. I subtract 10 from both sides. Give me 4x is equal to negative 1. And when I divide both sides by 4, x is equal to a negative 1/4. My solution is the point negative 1/4, comma, 5. That is my solution. The other is my work. Let's take the next equation. This time, if you'll notice that we do not have letters that when we add them or subtract them, they'll cancel out. That is going to happen occasionally. So your goal is to try to figure out which letter you want to knock out. And I'm choosing to knock out my x's. And so if I want to cancel out my x's, that means I need to multiply my first equation by 3 in order for us to get a common number in front of my x's. And so as long as I multiply the entire equation by that number, it doesn't change anything. So that gives me 6x. I am taking that 3 and I'm multiplying to each term, plus 21y is equal to 12. Now, if I want to get a 6 for that first part, I'm going to take my second equation and I'm going to multiply it by 2. That gives me a 6. But if I leave it just as 2, then that means when I add it, I'll end up with 12. But if I make it a negative 2, now when I add, I'll end up with a negative 6x plus 6x, and that'll cancel out. So I'm going to go ahead and mark it as a negative. And I want to take that negative 2 and distribute it through to each term. So plus 5y becomes minus 10y, and negative 5 becomes a positive 10. Now I'm going to come down and I'm actually going to work it just like what we did just on the last problem. And so my first equation is that 6x plus 21y equals 12. My second one is that negative 6x minus 10y equals a positive 10. Now, if I add these two equations, my x's will cancel out. And so, positive 6x minus 6x is 0x. 21y minus 10y is 11y. 12 plus 10 is 22. Now I'm going to solve that equation. 11y plus, or is equal to 22 by dividing both sides by 11, giving me y is equal to 2. I go back and I choose one of my original equations. I'm going to choose just that first one. I typically start with the first one unless some reason I think that the other one would be easier to work. 2x plus 7y equals 4. And I always go with the one before I multiplied. It's smaller numbers to work with. So 2x plus, I'm plugging in that 2 in for that y. And so I'm replacing that y with 2. And I am going to solve that equation. So 2x plus 14 is equal to 4. I want to move that 14 to the other side by subtraction, giving me 2x is equal to negative 10. I am now going to divide by 2 on both sides. And so I have that negative 10 divided by 2 is going to give me a negative 5. 2x divided by 2 is going to be x. So my solution is negative 5, comma, 2. And all I'm doing is putting them in order x, y. So it does get a little bit harder whenever they weren't the common ones, but when they are like this, we can easily add them. And so this one we already have, if I add the two equations, something's going to cancel out. So I'm just going to rewrite my equations to where I can work it. Now, when I add these equations, negative 3x plus 3x is 0x. Y minus y is 0. So they both cancel out. Unlike the last ones we've been working where only one is canceled out. When they both cancel out, you know you're at a point where you're either going to have a no solution or an infinitely many. In this case, because both sides gave us 0, that means this is a infinitely many solutions. And remember, infinitely many solutions is the same thing as us taking one of those two equations and saying that is my solution. That is where the description of my solution. Or that the system is dependent. The last one we are going to go over is 4x minus 6y equals 6, 2x plus 3y equals, negative 2x plus 3y equals 4. Okay, so example 4, we are going to need to cancel out one of the terms. And so I'm going to choose to try to cancel out my x's. If I multiply the first equation by 1 and my second equation by 2, then I'll have a common coefficient in front of my x's. So when I multiply that first equation by 1, that means AKA don't change it. I end up with 4x minus 6y equals 6. On my second equation, if I'm going to multiply it by 2, 2 times negative 2x is negative 4x. 2 times 3y is positive 6y. 2 times 4 is 8. So we are going to take those equations and we are going to work on adding them together to see if we can cancel out a term. So the first equation was 4x minus 6y equals 6. And the second equation was negative 4x plus 6y equals 8. When I add those two equations together, I end up canceling out my x's because 4x minus 4x is 0x. But also my y's end up canceling out again as well. So I'm left with nothing on that side, and nothing is going to be replaced with a 0 because 0 is nothing. But in no world that we live in does 0 equal 14. And so that's where this becomes the no solution. And that means that the system is inconsistent.